And now for something a little different, some notes on notation for the derivative function. So the derivative of the function y equals f of x with respect to x can be written in many ways, and that is largely due to these two handsome fellas right here. These are the main developers of calculus. This is Sir Isaac Newton over here, and this is Gottfried Leibniz over here. All right, so we got Newton and we got Leibniz. And back in the day, in the late 1600s, early 1700s, there was actually quite the drama between these two over who was the developer or inventor of calculus. So Newton and Leibniz were both working on this subject at the same time. And the current understanding is that Newton here actually began developing calculus first, but Leibniz was the first to publish a paper on it. So they warred over this for quite some time as to who was the real inventor. And honestly, at this point in history, we give them both a lot of credit, and we end up using both of their notations. So in the end, things kind of mellowed out, and we acknowledge them both for their contributions. So we've got these different notations for the derivative, and you've already seen one of them. This f prime of x, that refers to the derivative. With respect to x is just saying what is the independent variable here that we're doing things with respect to, what's the variable that's going to be up in the derivative function, that type of thing. So we've got f prime of x. We could also write the derivative, since, you know, we have y equals f of x. We could write the derivative as y prime. Okay, those mean the exact same thing. And these are both notations from Sir Isaac Newton there. So we've been using Newton notation thus far. Now, some other ways to write the derivative are dy dx, like so. Okay, and this, and another one we'll have here, are going to be Leibniz's notation. All right, and where this actually comes from is the idea that the derivative truly does represent the slope of a tangent line. So this comes from the idea of slope, okay, where, you know, slope, as we're used to it, would be a change in y over a change in x. So change in y over change in x. All right, and you know, we can use the letter delta to represent change, capital delta, that is, like this, the little triangle. We see that in the sciences, chemistry, physics. So we could say delta y over delta x, like so. And then for the idea of the derivative, we are taking that change in x smaller and smaller and smaller. And so as we do that, if you take delta x approaching 0 on this, this is just kind of a derivation for the notation, by the way, not a real formula that you need to memorize. As you let delta x approach 0, we say it gets smaller and smaller and smaller, infinitesimally small. And at that stage, Leibniz here decided to say, instead of delta x, I'm just going to say dx to show that this is representing something different. This is an infinitesimally tiny change in x. So this tiny, tiny thing, delta x, gets replaced with dx for the notation. And similarly, delta y on top is also very, very tiny, infinitesimal change in y. That's why we get dy over dx. Okay, so that's the idea of where this Leibniz notation is coming from. Now, he expanded upon that to use the d dx part. So you'll often see things like this, d dx. That means we are taking a derivative with respect to x of whatever comes after that d dx symbol or notation there. So if you're taking the derivative of f of x, you could write d dx of f of x like this. And then you would put in whatever your function is in there. So d dx of f of x means the exact same thing as dy dx, and that means the exact same thing as f prime of x, and that means the same thing as y prime. These all refer to the exact same thing. They're all just different ways of writing the derivative. Okay. So I'd say these four are probably going to be the main ones that we see most often. Okay, so that's good to know these. Get familiar with them. That way when you see one or the other, it doesn't trip you up or anything. They're all talking about the same thing. And there are also some less common notations as well. So let's note a few of these just in case you see any of these come up. We have different variations on these notations. If you see a y with a dot above it, that also means the derivative. This is a variation from Newton. So Newton variation, just using a dot instead of a prime. Okay. You could see Leibniz's like df dx, that could work. Again, that's very similar to kind of a combination of these two more common Leibniz notations. Okay, so this is a Leibniz variation. Okay, and then one more that we won't really see this in this class, but just to prepare you in case you see it somewhere else, capital D sub x also means derivative with respect to x of whatever comes afterwards. So if you see like d sub x of f of x, that also means the derivative with respect to x of this function f of x here. And that's kind of a funky one. Again, we don't really see that too often. This is from a third guy who decided to get into the fray. This is from Euler. Okay, so yeah, now we've got 7 different notations here for the derivative, and there might even be a few more variations that I didn't write down here, but these are the ones that we're mainly gonna see. So keep these guys in mind. All right, f prime of x, y prime, dy dx, and then d dx of anything that comes afterwards. That just means taking a derivative as well. So there we go.